In 2006, we removed it from the list of planets. We reclassified it as a dwarf planet, a small frozen body in the distant dark. But when we finally sent a spacecraft more than 4.5 billion miles into that darkness, what we found rewrote everything we believed. We expected a quiet, geologically dead rock. Instead, we found floating mountains of water ice, a sky tinted by red organic haze, and a vast pale plain of frozen nitrogen. For 76 years, from its discovery in 1930 to its reclassification, we called it a planet. Then we changed the definition. But this distant world is anything but dead. This is the true story of Pluto. Picture the journey of New Horizons. Nearly 10 years through the void, launched at roughly 36,000 miles per hour, the fastest spacecraft ever to leave Earth. As you travel outward, the sun shrinks from a blinding star into a brilliant point of light. By Pluto's orbit, sunlight is around 1,000 times fainter than on Earth, though still far brighter than a full moon. Stand on the surface at noon, and the sky would be black, a permanent, deep twilight. In July of 2015, New Horizons flew past Pluto, and the images stunned us. Across the equator sat a vast, heart-shaped region. The public called it cute. Planetary scientists saw something far more interesting. The western lobe of that heart, named Sputnik Planitia, is a basin roughly 1,000 kilometers across, likely the scar of an ancient impact, now filled with a deep glacier of frozen nitrogen, with traces of methane and carbon monoxide ice. And this glacier is not static. A faint amount of radiogenic heat from Pluto's interior drives slow convection in the nitrogen ice. The frozen surface churns over millions of years, like an extremely slow, boiling motion. This constant resurfacing is why Sputnik Planitia has almost no impact craters. It is one of the youngest surfaces in the solar system. Note that nitrogen is not toxic. It is simply inert and frozen solid at these temperatures. The true strangeness lies at the edges of that plain. Stand on its shore, and you would see mountains rising thousands of feet. On Earth, mountains are made of rock. On Pluto, the rock equivalent is water ice. At surface temperatures near -390 degrees Fahrenheit, water ice becomes as rigid and strong as steel. The peaks bordering Sputnik Planitia, ranges like Aladrisi Montes, rise as high as 10,000 feet or more, built entirely of water ice. And because water ice is less dense than solid nitrogen, large blocks of this icy bedrock appear to be buoyant. Fragments break away and are carried along the edges of the nitrogen glacier, like icebergs frozen in slow motion. Imagine a mountain range drifting, over geological time, across a plain of frozen nitrogen. Look closely, and the landscape carries a reddish tint. When ultraviolet light and charged particles strike methane and nitrogen in Pluto's thin atmosphere and on its surface, they trigger chemistry that forms complex organic molecules called tholins. These tholins settle out and coat parts of the surface in reddish-brown deposits. A frozen world of water ice mountains, tinted red by organic haze. For decades, we assumed Pluto was inert to its core. But there is a clue in Sputnik Planitia itself. The basin sits almost exactly opposite Charon, on the tidal axis, which suggests the heavy nitrogen ice acts as a positive gravity anomaly. The leading explanation is a hidden layer of liquid water beneath the ice, kept from freezing by pressure and residual internal heat. In the coldest reaches of the solar system, there may be a subsurface ocean. And wherever liquid water might exist, scientists ask whether the conditions for life could follow. For Pluto, we simply do not have the data to say. As New Horizons flew onward into the Kuiper Belt, it looked back and photographed Pluto backlit by the sun. The images revealed a layered atmosphere, multiple thin hazes glowing blue. That blue comes from sunlight scattering off the tiny Tholen haze particles, the same physics that makes our own sky blue, a delicate blue atmosphere around a distant world. But Pluto does not travel alone. Its largest moon, Charon, is about half Pluto's diameter, large enough that the two orbit a common center of mass, the Bare-Eye Center, which lies in empty space between them. They form a true binary system, and both are mutually tidally locked. From one hemisphere of Pluto, Charon hangs fixed in the sky, never rising or setting. From the opposite hemisphere, you would never see Charon at all. Charon has its own mystery. Its north polar region carries a dark reddish deposit informally named Mordor Macula. The current explanation is that methane gas escaping from Pluto migrates to Charon, freezes at its cold pole, and is processed by ultraviolet light into reddish tholins. Two worlds, chemically linked across the space between them. Orbiting the pair are four small moons, Nix, Hydra, Kerberos, and Styx, irregularly shaped and likely debris from an ancient collision that also formed Charon. Several of them tumble chaotically rather than rotating smoothly. They are the outer members of the Pluto system. We reclassified it. We labeled it a dwarf planet. But Pluto remains one of the most geologically active and surprising worlds we have ever visited, and a leading body in the Kuiper Belt. Red-tinted plains, water ice mountains, a possible hidden ocean, and a slowly churning nitrogen glacier. It will continue its orbit in the dark long after our sun becomes a red giant. And yet, for all its strangeness, Pluto is relatively calm. Travel inward toward the sun and you reach Neptune, a giant ice planet where winds can reach roughly 2,000 kilometers per hour, the fastest in the solar system, and where scientists believe the extreme pressure may turn carbon into falling diamonds deep in the atmosphere. But that is a story for another time. Keep looking up and stay curious.